Glad to have everybody back again. Alright, we're going to continue talking about special right triangles in this video. We're going to switch our focus from 45, 45, 90 or isosceles right triangles to triangles that are 30, 60, and 90 degrees in measures. So again, right triangles, you might wonder, since this is not isosceles or anything, what's so special about a 30, 60, 90 triangle? I plan on teaching you that, as well as the relationships between the side lengths of a 30, 60, 90 triangle. Okay, now first, what's special about a 30, 60, 90 triangle? Well, you might recall that I taught you that a 45, 45, 90 is half of a square when you draw its diagonal. Well, a 30, 60, 90 triangle can be created from an equilateral triangle. It's half of an equilateral triangle if you draw an altitude in that equilateral triangle. So let's say that I draw the altitude here. Now, first of all, we knew that that was an equilateral triangle, right, because it had two 60-degree angles, and thus it had a third 60-degree angle, which meant that all three sides had to be congruent to one another. Okay, so equilateral triangle, and whenever I draw that altitude, it creates two right triangles, and each is a 30, 60, 90 triangle, right, because this is a 60-degree angle, and that's a 90-degree angle. That's going to make this a 30-degree angle, and that's going to make this a 30-degree angle as well. Okay. So what are the relationships between the sides? Well, what I'd like to do is I'd like to call this little distance down here x. All right? And then let's try to reason out what the other distances in this picture are. Well, one thing I want to make sure we get here is that because of the reflection there, this distance would also be x, wouldn't it? All right, those were congruent right triangles, and these were corresponding parts of congruent right triangles. They have to be congruent to one another. And what that tells us then is the entire length of one side in this equilateral triangle is 2x. Okay, so let's focus again on a single 30, 60, 90 triangle then. What that means is that the hypotenuse of a 30, 60, 90 triangle has to be twice the length of the shorter of its two legs, because aren't all three sides of this equilateral triangle going to have to be 2x then? Alright, now also, as I use the word shorter leg, you remember that the longest side of a triangle is opposite the largest angle, so the hypotenuse opposite the right angle, and that the shortest side of of any triangle is opposite its smallest angle, so there's the 30-degree angle. Of the two legs, then, that makes this the shorter leg. All right, then what would the length of the longer leg, which is also the height of this triangle, be in terms of the shorter leg, or the hypotenuse, but it's really going to be in terms of the shorter leg here. Well, I called that h for height. It's not hypotenuse right there. That's the height of the triangle. And I want to, again, use Pythagorean theorem to show you the relationship between these three sides. This time we would have to say that h squared plus x squared is equal to 2x squared. Now, I'd like to solve for h here because I am trying to show you the value of this side compared to the other two. So let's get h squared by itself. Now I'm going to do two things at once here. I'm going to go ahead and square this 2x. 2x times 2x is 4x squared. And I'm going to go ahead and subtract this x squared from both sides. And then I'll simplify. That's going to give me h squared is equal to 3x squared. So then h, the height, is going to be equal to the square root of 3x squared. And as you'll recall, that means it's equal to the square root of 3 times the square root of x squared. And I'm going to bring this to the front. The square root of x squared is just x. And then the square root of 3 is going to remain a square root of 3. Alright, so what does that tell us then, really? That tells us that this longer leg, the side of the right triangle that's opposite this middle angle, the longer of the two legs, is equal to the shorter leg times the square root of 3. Now, this is always going to be true. No matter what 30, 60, 90 triangle you're looking at, the shorter leg is always going to, you can always double it to find the hypotenuse, and you can always multiply it by the square root of 3 to find the length of the longer leg. Now let's summarize that over here. I've got a 30, 60, 90 triangle. And want to make sure you know the different parts. Of course, hypotenuse, you know, is right here. Just trying to make sure we've labeled the terms that I'm going to be talking about. Here is the shorter leg. And the longer leg. And we just saw that if you call the shorter leg x, that you would double that to find the length of the hypotenuse. So the hypotenuse would be 2x. And that the longer leg is the shorter leg times the square root of 3. So it would be x squared of 3. Let me write out those relationships in words. Kind of verbal equations, I guess you'd say. All right, hypotenuse is twice the shorter leg. There you go. And the longer leg is a shorter leg times the square root of 3. You really need to memorize those two relationships between the sides of a 30, 60, 90 right triangle. Now let's put them into practice. I've again got some triangles for you where we're going to find the values of the variables, and all we're going to be doing here is using those 30, 60, 90 triangle relationships that we learned in the previous couple of slides. You see that I've got a 60-degree angle here. It's coincidental that this side is 30. It's not an angle measure. All right, don't be confused. This is the 30-degree angle. All right, that's just a 60-degree angle right there, 30, 60, 90. And, of course, you've got a 30, 60, 90 right triangle there as well. Now, in the first picture, what I've done is I've given you the length of the longer of the two legs. And you're supposed to find the shorter leg's length, and you're supposed to find the hypotenuse's length. And we really would prefer to do it in that order. The relationships that I gave you over here both told you how long the hypotenuse and longer leg were in terms of the shorter leg. It was in comparison to the shorter leg. It's always easiest to find the shorter leg first if you don't know that measurement. All right, so what do you do to the shorter leg to find the length of the longer leg? Well, you would multiply by the square root of 3. So we could say that m times the square root of 3 is equal to 30, right? Okay, now you could skip that step if this makes sense to you. Since you would multiply the shorter leg by the square root of 3 to get the longer leg, it ought to make sense then that you would divide the longer leg by the square root of 3 in order to find the length of the shorter leg. Inverse operations. Or you can use the equation that I just wrote out to figure out the exact same thing. And let's go ahead and rationalize our denominator. So we'll multiply the top and bottom by the square root of 3 over the square root of 3. That's going to give us 30 square root of 3 over 3. And then that, since the 30 and the 3 can do some canceling, is going to become 10 square root of 3. All right, so we found the value of m. Now, once you find the length of the shorter leg, always super simple to find whichever other missing side you have, in this case the hypotenuse. We know that the hypotenuse, n, has to be equal to the shorter leg times the square root of 2, right? So it has to be equal to m times 2 in this case, or 10 square root of 3 times 2. Now remember, with multiplication with radicals, only multiply inside numbers or radicands with other inside numbers, and multiply outside numbers with outside numbers. In this case, 10 times 2 I'd consider both to be outside numbers. You double 10 square root of 3, you get 20 square root of 3. I think that makes a lot of sense to you. All right, now in this second example, I've given you the length of the hypotenuse, and I'm asking you to find the length of the shorter leg and the longer leg. Okay, so we're going to use the fact then that the hypotenuse, 20 square root of 15, has to be twice the length of the shorter leg. Remember, find the shorter leg first. And then if we're going to find the shorter leg, what that means is we're dividing the hypotenuse by 2. All right, Q would equal 10 square root of 15. Easy. And then, once you've got that, multiply the shorter leg by the square root of 3 to find the longer leg. So, 10 square root of 15 times the square root of 3 that is going to give you 10 square root of 45. I multiplied my two inside numbers together there. And one last thing I'm going to do with this is that I notice I can simplify the square root of 45. I want to always leave my answers in simplest radical form unless I'm told around. So let's make that 10 times the square root of 9 times the square root of 5. And then the square root of 9 is 3, so we get 3 times 10 is 30. 30 square root of 5 is the length of the longer leg there. Alright, not that big a deal, right? Simple enough to use these triangle relationships that we're trying to learn. Okay, a couple more problems involving those. Here I want you to find the area of an equilateral triangle whose side lengths are 9 square root of 3 millimeters. Now we've already talked about how you can take an equilateral triangle and divide it into 30, 60, 90 triangles, and that's going to be the basis of what I'm going to do right here. Let's go ahead and draw our equilateral triangle. And the sides are 9 square root of 3. So I got 9 square root of 3, 9 square root of 3. 9 square root of 3 right there. And let's draw the altitude. Now, of course, in order to find the area of the triangle, we're going to multiply the 1/2 times the base times the height. Now, this is not a right triangle, the equilateral one is not, so we can't just multiply any two sides and then divide by 2 like we could with an isosceles right triangle. What we need to do is we actually need to find that height. And so, well, the 9 square root of 3 is going to be the base. Hopefully that makes sense the way I've got this drawn. When we draw the height, we've already seen how that cuts the base in half. So this part would be 4.5 square root of 3, correct? And then the height, let me label that right here. Well, this is a 30, 60, 90 triangle. Remember that the angles of the equilateral triangle are 60 degrees, so this would have to be a 60-degree angle, meaning this is the 30-degree angle, and this is the shorter leg then of that triangle. And we're going to multiply that by the square root of 3 in order to find the length of the longer leg. So h equals 4.5 square root of 3, the shorter leg, times the square root of 3. And that's going to give me 4.5 times 3. The square root of 3 times the square root of 3 is the square root of 9. That's 3. And then 4.5 times 3 is 13.5. Alright, so we now know the height of the triangle. We already knew the base. We can go ahead and find the area. Alright, now one of my favorite little tricks with this is knowing that I don't want to redo work. I've already found out what half of the base is. Whenever I drew the height here, that divided the base of this triangle, equilateral triangle, into 2, didn't it? So this 4.5 square root of 3 is half the base. Remember, it's the equilateral triangle we're finding the area for. So we already know half the base is 4.5 square root of 3. Now we know the height is 13.5. Again, multiply your outside numbers together here. And you're going to find that the area is 60.75 square root of 3 square millimeters. All right, very good. One more problem in this video. Again, I want you to find the value of the variables in this problem, but you're going to notice there's not a right triangle involved. And so what I'm going to do is show you an instance, and there are several, where you can take something that's not a right triangle and use right triangles to help you solve it. And in this case, special right triangles. You notice how the two angle measures that I gave to you in this non-right triangle are 45 degrees and 30 degrees. Well, those add up to 75, right, which makes this a 105-degree angle. So again, it's not a right triangle. But if we go ahead and draw the height of that triangle, it does create a couple of right triangles, and those right triangles are going to be they're going to be what we call the special right triangles, aren't they? You've got a 45-degree and a 90-degree angle there, so you got a 45, 45, 90 triangle. And here you had a 30-degree angle, and now you got a 90-degree angle, so you've got a 30, 60, 90-degree triangle. Okay, now also keep in mind that x is this entire side length, it's not just part of it. That's going to be important later on. Well, we've only been given one measurement, and so in our process of trying to find x and y, we're just going to have to start off with using this 18 square root of 2. Now, that's the hypotenuse for a 45, 45, 90 triangle. The only thing we're going to be able to do with that is to find the lengths of the legs of the triangle. And that is actually going to be helpful to us. So, now, remember, you divide the hypotenuse by the square root of 2 in order to find the lengths of the legs in a 45, 45, 90 triangle. 18 square root of 2 divided by the square root of 2 is just 18. So, that's going to be 18. This is going to be 18 as well. Now that 18 on the bottom only goes from here to here, so it's not the value of x. We're going to need to find out what this distance is right here as well before we can find out what x is. All right, we'll get to that shortly. In fact, right now. So we do have one more distance to find in order to find the value of x, right? This one right here. And that happens to be the length of the longer leg of this 30, 60, 90 because it's opposite the 60-degree angle. It's the longer leg. And remember what you do with the shorter leg, which you know, to find the longer leg is you multiply by the square root of 3. So there, this is 18 square root of 3. Now we know the value of x can be found by adding those two distances on the bottom together. 18 plus 18 square root of 3. And it turns out that's as much, if you're going to leave this as an exact value, as you can do with that expression. All right, you cannot add a term with a radical, this one right here, with one that does not have a radical. You could multiply them if you were trying to, but you cannot add them that way. They're not like terms, kind of like trying to add 18 plus 18x. You couldn't do it. All right, good. We got the value of x. Now the value of y, we will simply find by finding the hypotenuse of that 30, 60, 90 triangle, which is twice the length of the shorter leg. Well, so y is going to have to be 36. All right, I hope you find these 30, 60, 90 triangles pretty simple to work with. They're really not that bad, but you need to memorize what the relationship between the hypotenuse and the longer leg is with the shorter leg. Thanks for your attention. See you later.